So here's a simulation by PhET Simulations. It's called Reactions and Rates. Visitors in this simulation can explore how reactants are transformed into new products. Here's the reaction that we'll be studying through this little video. So in this particular reaction, we have two reactant molecules. We have reactant molecule A and reactant molecule BC. They'll be transforming into product molecules A, B, and C. For those of you with a little bit of a chemistry background, you'll notice that this is not a combustion reaction. It's actually a single replacement reaction. We are a little bit limited in the type of reaction that we can analyze within this simulation. However, the purpose of this video is to simply emphasize how collisions occur and allow reactants to transform into those new products. So let's start by adding in some reactant molecules. So we'll start by adding in reactant molecule A, followed by reactant molecule BC. Now what you'll notice initially is that these reactant molecules are moving fairly slowly, so the energy within this reaction is quite low. Some collisions are occurring, however, those collisions are not yet resulting in any new products being formed. So in order for reactants to transform into products, there must be collisions between the reactant molecules. But those collisions must also contain enough energy in order for existing bonds to be broken and new bonds to be formed. The collisions must also occur in the correct orientation. In other words, the reactant molecules have to be hitting one another in the right location. Now, if I increase the temperature within this reaction, you'll notice that the molecules start moving very rapidly and that collisions become more frequent. You'll also notice that more of those collisions are resulting in products being formed. Now, this bar graph also shows that the reaction is proceeding in both directions. Taking a look at our reaction equation, these arrows show that the reaction can proceed in both the forward direction and in the reverse direction. Over time, the reaction should achieve equilibrium in which the rate of the forward reaction equals the rate of the reverse reaction. If I pause this simulation, we can look at all of the molecules that are present. So again, we have the initial reactant molecules A and BC, and the initial product molecules A, B, and C. This is just one of the simulations that I often use with my students. I really enjoy using PhET simulations to help students better grasp abstract ideas. And again, this is just one of the ones that I use on a fairly regular basis.